In this question, you are asked to prove that 0 to pi by 2 sin x by sin x plus cos x dx is equal to pi by 4. So let us use properties of determinants to prove this result. So this is a very standard question. Questions like this will be asked very frequently. So let I is equal to integration 0 to pi by 2 sin x by sin x plus cos x dx. So this integration is of the form 0 to pi by 2. It is 0 to some number a. So we have a property which says that 0 to a fx dx is same as 0 to a f of a minus x dx. That is, in the place of x you can substitute a minus x. In this question a is pi by 2. So in the place of x if you substitute pi by 2 minus x, the integral won't change. So I is equal to integration 0 to pi by 2. So in the place of x if you put sine of pi by 2 minus x by sine of pi by 2 minus x plus cos of pi by 2 minus x dx. This integral is also equal to I. So if you simplify this integral 0 to pi by 2, sin pi by 2 minus x, we know that it is cos x. By sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x dx. So this is also equal to I. This is also equal to I. So let us add these two. So 2I is equal to integration 0 to pi by 2. So both the limits are same. So you can add the integrals inside. So sin x by sin x plus cos x by sin x plus cos x. So sin x plus cos x by sin x plus cos x dx, that is equal to integration 0 to pi by 2 1 dx, that is equal to x from 0 to pi by 2, which is equal to pi by 2. So 2I has turned out to be pi by 2. So I is equal to pi by 4, right? And I is nothing but the given integral. Hence proved. So I have proved that this integral is equal to pi by 4. So this is the most useful property among all the different properties. Correlation.